Hey everybody. Okay, we are going to start looking at functions, okay? So you've kind of sort of been exposed to this already, and when we started doing graphing, we talked about things called making tables, right? We were, without using that kind of language, we were exposing you to working with functions. So the whole idea behind a function is if a function is a use. A function is something, it does something, right? So you can almost think of a function as sort of a math machine. It's like something goes in and then you kind of figure out, you do something to it and then something comes out, all right? And that's what a function is in a nutshell. So in this video, we're just gonna quick kind of talk about what it is and sort of introduce you to it. So what a function is, so for example, if I said to you, okay, I'm going to put a number in. I'm going to put the number 7 in. And I'm going to put it into this mysterious box. And then out on the other side of the box, it comes out as a 10. All right? So think of like a toaster. You put bread in, right? You push the toaster down and it serves a function. And out comes toast. So you put something in, you get something different out, right? So with this function here, I put 7 in, I get 10 out. All right, well, supposing I put in 11 and I get 14 out. And at some point you should start to see, well, it looks like what's happening is it looks like it's taking whatever you're putting in and you're adding 3 to it. Okay, so I'm taking whatever the number is and you put that in the box, you add 3 to it, and then that's what your result is. So you have your input that's going in, right, which is all the stuff that's going in over here, and then your output is what you get out of it. Right? And that's the basic idea of how a function works. Obviously, they get much more complicated than just adding 3 to a number, but that's the general premise. That's kind of how they work. All right? So with functions, they have their kind of their own language and their own sort of code, like symbology that they use for it. So if you see this picture right here, right? Your input always goes in for your x, all right? So input x is any real number, and they say that's the domain. So the domain is always your x values in anything. That's what you can put into something. And then the range, or your output, is what you get out of it, okay? And so when they write these, okay, they always use this function notation, which is, they say, they write it as f of x equals. So here, I'll show you, I'll put it in an example of something that will be familiar to you. If you look at slope-intercept form, right, you got y equals mx plus b. If I were going to write this as a function, I would replace y with f of x equals mx plus b, which means that I will put a number in for x, right? The function of, so this function will take that number, it will put x in right here, and then it will multiply x by m, and then add it to b, and then what is left when you're done gives you this value, this f of x value. So you can think of f of x as kind of also being the same thing as y. Y is always your output, x is always your input. And it's that way with any graph. If you have a graph, that's why we call your x values, right? That's why we always say those are your independent variables. And your y is your dependent variable. And the reason it's your dependent variable is because it depends upon what you put in for x, right? And it all comes back to input, output. You put something in, you get something out, all right? Now, if we look a little more closely at this writing, like how they say it, the way we read this, and it's going to be important that you kind of understand this moving forward in the video, right, is I would read this and I would say the function of x, right? Function of x, right, is equal to, and then whatever this is, right? But the way they usually say it is they say f of x. It means the function of x, but almost everybody says f of x. F of x, that's how we read it because we're lazy and don't want to say function. But f of x is equal to 5x plus 3. This means that whatever value you put in for x, you're going to find the x in here, you're going to put that in, and then you're going to do this stuff to it, and then you're going to get your number out. All right? So this is kind of like how basic functions work in the basic function notation. So we're going to kind of do a couple simple problems here to wrap this video up. All right, so let's take a look at this. It says find each function value. So what this means, and the way I would read this, I would say find the function, the value of the function if I put 2 in for x. That's what the f of 2 means. F of 2 if f of x is x plus 4. Right? So I know that this f of x equals x plus 4 is my general function value. Right? Sorry, that's being really glitchy. So now what I'm going to do when I write f of 2, it means I'm going to find wherever x is, which is right here, and I'm going to put 2 in for it. So I'm going to go 2 plus 4. I usually put it in parentheses to show that I'm substituting it in. And then f of 2 is 6. Similarly, with this same function, if I wanted to find out what it was if I put 10 in, I would say f of 10 equals 10 plus 4. And you just add 10 to 4 and get 14. All right, let's look at number 2. So number 2, f of 9 if f of x equals x minus 8. So again, you're just going to write your function out, right? F of 9, and I'm going to write this out except where I have x, I'm going to replace it with that number. So I'm going to write it as 9 minus 8 because that's f of 9. F of x is the general form of it, and then when you put that number in, it's telling you you're working towards a specific value. So f of 9 equals 1. And then if I use another number, supposing I use negative 2, right? So that means I would take negative 2 and I would put it in place of x. So all you're ever doing is substituting this, right? Then you have negative 2 minus 8, which is negative 10. Remember, when both the signs are negative, it's basically like you're adding it, and then you keep the sign. All right, let's try a couple more before we move on to tables. All right, so f of negative 5 if f of x equals 4x plus 2. So a little more complicated here, all right? So that means I'm going to write it out, f of negative 5, and I'm going to write 4, and then where I see x, I'm going to put this negative 5 in. So 4 times negative 5, if it'll let me do that. Okay, 4 times negative 5 plus 2. So 4 times negative 5 is negative 20. And then when you add 2 to negative 20, that's like being on the number line and going to the right 2 spaces, which will put you at negative 18. So f of negative 5 equals negative 18. Similarly, if I used a positive number for this, supposing I want to find out what f of 8 is, I'll just go 4 times 8. So hopefully you can see that all you're doing is just substituting in these values that are right here into the equation wherever you see that variable. So if we're replacing x with 8, you got to find x in the equation and put 8 in place of it. So 4 times 8 is 32 plus 2, 34. All right, and then last problem here, let's try problem 8. So f of negative 3, so I'm going to go f of negative 3, and I'm going to start writing this equation out, except where I see x, I'm going to put this number in. I'm going to put negative 3 in, and minus 4. And so then it's just a matter of computing it. So negative 4 times negative 3 is positive 12 minus 4, which is 8. And if I did another number, supposing I did f of 6, all right, then you would go negative 4 times 6 minus 4. And so negative 4 times 6 is negative 24 minus 4. They're both negative, so you add them up and keep the sign. So negative 28. So these aren't terribly complicated. You're going to have to be really comfortable with working with integer operations. A lot of multiplying, adding, and subtracting with these. So definitely want to shore up your skills in that area. All right, next video we're going to talk about tables, function tables.